Have you ever wondered why a rubber band snaps back, but a paper clip stays bent? It's all about material properties. These properties determine how things behave under stress, pressure, and heat. Understanding them helps us build bridges that stand strong and phones that are light but durable. It's like having a superpower, the ability to decode the world around us. Elasticity is the ability of a material to return to its original shape after being stretched or compressed. Think of a rubber band. You stretch it and it snaps back. That's elasticity. Steel is another great example. It can withstand a lot of force and still spring back to its original form. This property is crucial in construction, where materials need to handle stress without permanent deformation. Plasticity is the opposite of elasticity. It's the ability of a material to change shape permanently under stress. Imagine molding clay. You can shape it and it stays that way. That's plasticity in action. Metals also exhibit plasticity, especially at high temperatures. This property is essential for processes like forging, where metal is heated and then shaped into tools and machine parts. Section 4. The pull of ductility and the shatter of brittleness. Ductility is a material's ability to be stretched into wires without breaking. Think of copper being drawn into thin wires for electrical wiring. That's ductility. On the other hand, brittleness is the tendency of a material to shatter or break under stress. Glass is brittle. Drop it and it shatters. Concrete is another example. Strong under compression, but brittle under tension. Section 5. The hammer and anvil of malleability, toughness, and hardness. Malleability is similar to ductility, but it refers to a material's ability to be hammered or pressed into thin sheets without breaking. Gold is incredibly malleable, which is why it's used to make delicate jewelry. Toughness is a material's resistance to fracture or breaking. A tough material can absorb a lot of energy before it breaks. Hardness, on the other hand, is a measure of a material's resistance to scratching, indentation, or wear. Diamonds are incredibly hard, which is why they're used in cutting tools. Section 6. Strength, creep, fatigue, and resilience. The endurance of materials. Strength is a material's ability to withstand applied forces without breaking or yielding. Creep is the tendency of a material to deform permanently under long-term stress, even if the stress is relatively low. Think of a plastic ruler bending over time if you leave it weighted down. Fatigue is the weakening of a material under repeated cycles of stress. Imagine bending a paperclip back and forth until it breaks. Resilience is the ability of a material to absorb energy when it is deformed elastically and then release that energy when it springs back to its original shape.